to say this is gibberish. I don't understand anything. I want clarification. So I'm going to clarify everything step by step. As x approaches 0 from either side, infinity. As x approaches 0 from the left, infinity, 0 from the right, infinity. Done. A limit as x approaches 3 from the left. Okay. 3 from the left, negative infinity. Done. 3 from the right, infinity. Done. Limit of f of x as x approaches negative infinity, 1. Okay. Y equals 1, horizontal asymptote. Done. And as x approaches infinity, the function values approach negative 1. Y equals negative 1, horizontal asymptote. Done. So I'm going to analyze here. So if as x approaches 0, both sides go to infinity. Obviously, for me, this means x equals 0 is a vertical asymptote. At 3, on this side, it goes to infinity. On this side, it goes to negative infinity. Obviously, x equals 3 is a vertical asymptote. Now, this is so clear. All this here, it's just foreign language to me. Now, everything is extremely clear. I put everything where it belongs. I analyze that, what I know, if x approaches negative infinity and the function values approach 1, that's a horizontal asymptote. The same thing here. On this side, both go to infinity, 1 to infinity, 1 to negative infinity, vertical asymptote. In between, you can use your imagination. Okay. I will start with this. I cannot just show one side of a line. I cannot, if this is a line, I cannot just show this piece here or here. I have to show the whole thing. So this is y equals 1. Also, y equals negative 1. Now I have to graph x equals 0. There is no need, it's already there. Now I have to graph x equals 3. So I positioned the vertical asymptotes, I positioned the horizontal asymptotes, and now I'm ready for the graph. As x approaches negative infinity, approaches 1. I don't know if it's above or below in a moment. Oh, it goes to infinity, so it must be from above. Here comes from positive infinity. And on this left-hand side, it approaches negative infinity. Fine, okay, no worries. A rational function or a function can cross a horizontal asymptote. It cannot cross a vertical, but a horizontal, yes. It's okay. Here, from positive infinity to negative 1, okay, so it's coming from positive infinity and going to negative 1. So this is my example based on the given information. Make sure when you graph that this is a function by the vertical line test at any point in time. So you can't take this and do whatever. Be very careful. So if these branches overlap, that's no longer a function. By the vertical line test, it's not a function. So after I finish my graph, I take a moment and look. Okay, wait. Oh, yeah, it's okay. Very good pick. It was an interesting problem. Thank you. Any questions on this? Okay, now we still have a lot of work in this section. I'll open it for your suggestions. Okay, we're looking at 15 through 42. Anything, 15 through 42. They are, I don't want to say million because of course they're only 15 to 42. but everyone is different. Everyone, tons, I would say, although only from 15 to 42. Okay, so let's choose.
22.
Okay, so perfect. Pick. Let's start with 22. Let me copy it. Make sure I copy correctly. Limit u approaches negative infinity, u squared plus 1 to u squared minus 1 over u squared plus 2 to the second power. Excellent. Okay. Now, in this particular situation, I would like, although I always tell you, and now you're changing the rules on us. No, I'm not. I always tell you, leave the denominator alone. Do not ever expand the denominator. Here I have to expand the denominator to show you what's happening and what I need to do. So, but in general, 99.99% we don't touch the denominator. We want it factored, but this time I'll have to. Okay. So remember what I said always? Every time we're asked to find the limit, that's why I need my props. Every time I'm asked to find the limit, plug it in. I can't at this point. It's not clear. It's not obvious. I'm going to have to do a little bit of work on this function, and then, of course, I will. Good. So then do not drop the limit operator. We have not applied it. So u approaches negative infinity. Okay, so this is easy. U squared times 2u squared is 2u to the 4th. U squared times negative 1 is negative u squared. 1 times 2u squared positive 2u squared. 1 times negative 1 minus 1. I know how to square a plus b squared. Always quickly. A squared plus 2ab plus b squared. A squared, u to the 4th, plus 2 times the first times the second, or times the first times the second, it doesn't matter. It's 4u squared plus the second term squared. Simplify by combining like terms. Limit u approaches negative infinity, 2u to the 4th, plus u squared minus 1 over u to the 4th, plus 4u squared plus 4. Okay. There is something we know from pre-calculus, but I'm not going to quote it right now because I need to explain what happens here. Anyway, we can discuss it later. Okay, we know the answer from pre-calculus, but I don't want to work on that. Okay, so I need to show you what's happening here. At this point, I have the expanded form. I have to see what happens when u approaches negative infinity. This is a polynomial. This is a polynomial. Which of these three terms is the most powerful when u approaches infinity or negative infinity? Doesn't matter. Which of these three terms at infinity is the strongest?
U cubed, or u to the 4.
Okay, so these two don't even count. At infinity, not when I plug in 5. When I plug in 5, all terms count. But when I plug in infinity, or I think of the trend at infinity, these two are too small to mention. So then when u approaches negative infinity, where is this going?
Positive.
What? Exactly. Positive what?
Infinity.
Excellent. So we repeat the same procedure for the denominator. When u approaches infinity or negative infinity, doesn't matter. Which of these three terms is the most powerful one?
U to the 4 again.
Right. So then where is this denominator going?
Towards infinity.
Good. So far, we only saw from the 7 indeterminate cases, we only saw one of them. This is the second one. Later on, we are going to add more. There is a total of 7. We encounter this, and this is the second one. We have 5 more to add, step by step. Okay, so now you know what lazy people do. Okay. In this situation, I'm going to ask again, what is the degree of the numerator? The degree. 4. Very good. I will factor out. And you can say, no. No, you can't do that. U to the 4th is not a common factor to all 3 terms. And I will say anything can be a common factor to anything I want. So stop for a second here. Yep. And here's how it works. If I have 5x, can I factor out x to the 5th? No, because x to the 5th is not in there. But yes, I can. I can factor out anything I want, as long as this product is still 5x. And this product is still, oh, I wanted 4 here. And this product is still 5x. Because when I simplify, 5x to the 5th over x to the 4th is x. From 5x, I can factor out 1,000 if I want to. How come? Yeah, as long as I have 5x over 1,000 in here. I can factor out from 5x a to the 3rd. How come? Yes, as long as I have in parentheses 5x to a to the 3rd over x a to the 3rd. I can do whatever I want. Exactly what we're going to do here. We're factoring out the degree. As long as I write 2 plus 1 over u squared minus 1 over e to the 4th, I'm fine. How come? Let's check. U to the 4th times 2, that's correct. U to the 4th simplify with u squared, I have u squared. And negative 1 over u to the 4th times u to the 4th, I get back negative 1. I will repeat the same process because it happens that the degree is the same, u to the 4th. Can I? Yeah, of course. 1 plus 4 over u squared minus plus 4 over u to the 4th. Does it work? Of course. U to the 4th times 1 is that. U to the 4th times 4 over u squared. When I simplify these two, I get 4u squared. And when I multiply these two, I get back 4. And now, yes, that's what I was hoping for. And now, based on what we wrote, this here, I'm going to ask you, where is this going? Where is this? Yes. Where is this going?
0.
And where is this going?
0.
So if those are zeros, they are gone. What is my limit?
1 or 2.
Exactly.
2.
See, my props are very helpful. So what does that mean? The limit of a function when x or u approaches negative infinity, if I get a number, what does this say?
Has a horizontal asymptote.
Horizontal asymptote. Yes, in pre-calculus, we taught our students same degree over same degree. The answer is 2. As long as it's x or u approaches infinity or negative infinity, and it's the same degree over same degree. It's the leading coefficient over the leading coefficient. But here we go further, and we explain why this is the case. it happened that both degrees were the same, but I do not look at the denominator when I factor out the degree in the numerator. They may or may not be the same. I don't care what this has. I will factor out the degree and the degree. If it happens that they are the same, fine. But one does not depend on the other. I factor out the degree, period. Whatever the degree is.